A trinomial has three terms. We'll often represent a general trinomial as ax squared plus bx plus c, where a, b, and c represent numbers that multiply x squared, x, and then the constant term at the end. It turns out when you're factoring trinomials, that a value makes a big difference in how hard the process is or how long the process takes. What we're going to do is look at the easy part first, the easy technique, which is when a is 1. So we're going to look at first factoring trinomials where you start with an x squared and then you have something times an x and then a constant term. So we're going to look at factoring these types of trinomials first, and then we'll move on once we get used to this to the harder case where a could be anything. To factor a trinomial, remember we want to write it as a product of binomials. So we're going to write a parenthesis for each of the binomials out first. Now the nice thing is that this x squared term, because remember we wanted to simplify it down to just x squared, is going to factor directly into x and x. So this factors directly into x and x in the very beginning of the term. What we're then going to do is think about factoring the constant into the other position that's left in the binomial. And the trick for making this work is that we want to look for factors of c that are going to add up to the middle coefficient of b. Now that's easier to see in a specific example. So here's one, x squared plus 10x plus 16. What we want to do, again with any trinomial, is start by breaking it into two binomials that are multiplied together. The x squared goes into the first location as x and x, and then again, the c value is 16. I want to think about factoring the 16 so that I get something that adds up to 10. And then that should work in terms of this factoring process. Now, factoring 16, there's not just one way to do that. If we start from the basics, 1 always goes into any number, so 1 times 16. 2, since 16 is even, can be multiplied by 8 to get 16. 3 won't go into 16, but 4 will go into 16 4 times. So it turns out there's 3 pairs of factors here. The good news is that only one of them will add up to the middle value that we have there of 10. And when we think about summing these up, the sum of 1 and 16 is 17, 2 and 8 is 10, there we go, and 4 and 4 is 8. So as I mentioned, only one of them will give you the right sum that will take us to the middle term. So we're going to use the 2 and the 8 here in the second position. Notice these are both positive numbers, so I use plus 2 and plus 8. And now let's check this by multiplying out. X times x is x squared. The outside terms would be positive 8x. The inside terms would multiply to 2x. The last terms, 2 times 8, would be 16. Combine the middle terms, we get x squared plus 10x plus 16, and compare that to where we started. That is exactly where we started, so that checks. So our final answer, when we factor the trinomial x squared plus 10x plus 16, is a product of these two binomials, x plus 2 times x plus 8. Here's a few more examples. This process does definitely take practice getting used to. All three of these are trinomials. We're going to start with binomials, because we know we're going to take a trinomial to the product of two binomials. The x squared goes to x and x. And then if I want to see what goes into the other positions, I take my constant here, 12, and I look at all of its factors. 1 and 12, 2 and 6, 3 times 4. And notice how, because I was doing this in order, 3 and 4 rotate back around, so I've actually found all the factors of 12. Now we want two factors that add up to 8. 2 and 6 add up to 8, so I would put a plus 2 and a plus 6 in right here. And we could check that by multiplying. X squared times x is x squared plus 6x for the outside plus 2x for the inside plus 12 for the last terms. The middle terms add up to x plus 12, and there we have our result. That's where we started. So this really is our factoring result. Next example, y squared minus 10y plus 9. Factor into binomials. So set up your parentheses. We've got a y squared here, so instead of x and x, this will be y and y. Now we look at a 9. We factor 9, 1 and 9, 3 and 3 are the only pairs of factors. Now when we add those up, none of them add up to -10. The sign matters here. So let's think about this a little bit more. If I want to have two numbers that multiply to 9 but add to a negative, so multiply to a positive but add to a negative, using two positive factors won't do that. But if we use two negative factors, two negatives will add up to a negative. So when I sum these up now, I can get a -10 when I use -1 and -9. So -1, -9 should be the factors I use here. Checking this, y times y is y squared. Outside terms, -9y. Inside terms, -y. And last terms, +9. So I get y squared minus 10y when I collect like terms plus 9, which is exactly where I started. Next example, y squared plus 3y minus 28. Again, a trinomial will factor to a two binomials, so set up your parentheses. The y squared goes to y and y. And then we take our -28, and you do need to make sure you use the sign, and we're going to look at pairs of factors. Now, if I just start with the 28 by ignoring the negative, I'm going to have a 1 and a 28, a 2 and a 14. 3 won't go in, but 4 will go in 7 times. 5 won't go in, 6 won't go in, so I've reached everything I need to look at. But I have ignored the sign here. Two positives don't make a negative when you multiply out, so one of these has to be negative. A -1 times a 28 will make a -28. -2 times 14, -4 times 7. Now what we want is that +3 to be the sum of one of these. And if we look carefully through and add these each up, -4 and 7 will make that +3. So I'm going to use a -4 and a +7 here. So remember, if your constant at the end is a negative, you're going to need to use one of each sign when you factor that out. So checking this, y times y is y squared. Outside terms, 7y. Inside terms, minus 4y. And then finally, negative times a positive would give me a -28 for the last terms. Collecting those terms in the middle gives us +3y. And so we have exactly what we started with, and that checks. Last example here, we have something a little bit different going on. We have an x squared, but we also have a y squared in here. You can still factor the same way, setting up, because it's a trinomial, into two binomials, so using your parentheses. The x squared still goes to x and x, and we're going to still use the -30 to factor with, but the y squared is going to tag along with whatever numbers we use for -30. So you can just go ahead and split the y squared up into those last positions. Now let's look at -30. Because it's a negative, we need one of each sign. So I'm going to start out with -1 and 30, -2 and 15. 3 will go in, use a -3 and times 10. -4 won't go in, but -5 will go in 6 times. Now when we go to add those up, none of those add up to a -1, but this last one is really close in that it's a +1. Remember, we just kind of randomly chose to make the first number in the pair of a negative. If I had made this first number in this pair a positive and the second number a negative, I still get a -30, but that switches what it adds up to. Now my sign when I add these up is going to be a -1. So it turns out if you get the right number but the wrong sign when you're adding these up, you just have to switch the signs. Very easy. So I'm going to use a +5y. Remember, these numbers connect with the y, and a -6y. So this will be my factorization. Let's check it. FOIL this out. X times x is x squared. Outside terms are -6xy. Inside terms would be +5xy. Last terms would be -30y squared. Take those middle terms and combine them. -6xy plus 5xy would be a -xy, -1xy, minus 30y squared. That's exactly where I started, so this checks. Again, a trinomial will always factor to the product of two binomials. So immediately set up your parentheses and go from there.